find out the difference between each and every category with the selected subcategory. So how to achieve this? So I'm connecting to Superstore. So I'm taking category and I'm taking sales. So here what I would like to do is, here if I select any category, the requirement is to find out the difference between the selected category and the remaining categories. So let me add a selection on the category field. Let me create a parameter with the name category. So the data type is string and the values are list. So just click on add from field and we can add the values from the existing field. So here I'm having the category field. Just hit OK. So now after adding the category parameter, here if I select any category, for example, if I click on labels, the requirement is to compare this label sales with the remaining categories sales. So here I'm creating one calculated field with the name selected category sales, and here just specify if category equal to my selection. So how to get selection using the parameter? So then display sales, else 0. Let me end this. So here just I'm taking if my category equal to the parameter category, then give me sales, else 0. Just click on apply and click on OK. Now drag the selected category sales and drop it into columns. Okay, here it is showing us this category sales in this particular selected category sales, and these are the sales of each and every category. Let me select any other category. Let me click on paper. If I click on paper, it is showing us only the paper category sales. Here what I want is, here I want this selected category sales in every row, because the requirement is to compare the difference of the selected category with the remaining categories. So here how to get the difference? So to get the difference, so basically the difference means what? Sum of sales minus sum of selected category sales, right? So we take the difference. I'm taking difference. So what would be the difference from the sum of sales minus selected category sales? Okay, so again here I have to take the aggregation sum of selected category sales. So just click on apply and click on OK. So now if I drag the difference, it is going to show us the difference only for this row. So if I click on ABC, here Tableau is showing the same value, because for all the remaining categories here I have taken what the value as 0. So we see here the logic is, if category is matching with the parameter, then show me the sales. So here the category is matching because my selection is here paper. So it is showing that value in only in this row. Here I want the values in every row. Here I want the selected category values in every row. So how to get the selected category values in every row? I'm creating a calculate field with the name every row. So just take the logic here. So how to get the values in every row? So to get the values in every row, so just we have to use an LOD. I'm taking exclude subcategory, category. Just I'm excluding category and I'm taking selected category sales. I'm taking selected category sales. Okay, sum of selected category sales. Sum of selected category sales. Okay, here from this visualization, just I'm excluding the category in every row. So and I'm getting the selected category sales. So just click on apply and click on OK. So exclude category means in my view I'm having category, and in my LOD I'm having category what exclude will do. Exclude will exclude both the values, and just in every row it is going to give us what? It is going to give the selected category sales. So what the selected category sales contains? Just this category sales. Simple logic. So just drag that selected category sales every row, just drag it and drop it into the, okay, just drag it and drop it into the columns. Now it is showing us that value in every row. Now it is showing us that value in every row. So next after placing that value in every row, just here you have to find out the difference. So in the difference, just simply take instead of taking sales, just take that every row, just take it every row, right? So now click on apply and click on OK. So I think it is showing us the wrong value. I think I have to take, let me place the value again. Just I'm going to the difference. So the difference is what? Sum of sales minus sum of every row. It's sum of sales minus sum of every row. Sum of every row. So click on apply and click on OK. So once drag the difference, drag it and drop it into the columns. Here we got the difference. Just sort it in the descending order. Now just go to the difference, drag the difference and drop it into color. So now here if you select any category, for example envelopes, now it is showing the values dynamically here. It is the envelope value. So I'm removing this. So this value is the difference of this value and this value. And this value is the difference of this value and this value. So here we are showing the difference of each and every category with the selected category, right? So it's all about the LOD's first level tasks. So any questions? Any question on this task, please? Any question on this task? LODs requires a lot of practice. Within the first glance, you cannot understand it in the proper way. So if you practice it for like 2 to 3 times, then you could get the correct logic. All right. So yes.
By seeing the requirement, how will we decide or know that we have to use LODs or we have to go with the traditional approach? How to differentiate it?
Yes, even it depends on the understandability of the question. So that's why in BA, understanding the question is very, very important. So
with experience, I know it might come, but is there any thumb rule or anything which we can say, okay, we have to use LODs and go with a different approach rather than researching on the original?
Yeah, that's a tricky question to answer. Yes. So one basic thumb rule is when we have to go for the table calculations means if we want to compute ranks, okay, then go for the LODs. Or if you want to go, then go for the table calculations. Only for the rank calculations and only for the top bottom and analysis. Go for the table calculations. For the remaining tasks, just go for the LODs. You could remember this thumb rule, because the same task can be achieved using the LOD and the table calculation. But the drawback of the table calculations is the table calculation is executed at the Tableau level. So it requires the complete data has to be pulled into the Tableau. So it will take a lot of time while working with the real-time data sources. So just go to the table calculations only while computing ranks and while performing top bottom and analysis. The remaining, every task just do with the LODs.
Yeah, and also on the LOD part, right, and also we are seeing a lot of samples, right? The type of questions that are asked are different. I mean, yesterday you gave some theory part on how at what level the LOD types of LOD and all this, right? So the questions will be on the problems or on the theory part.
So is this question specific to the interviews or in the real time? Actually, your voice is breaking. So that's why I'm
Interviews.
asking. Yeah, in the interviews they'll ask like what are LODs, what are the limitations of LODs, and how each and every LOD will work, and even they'll give some tasks and they want you to answer those tasks.
Okay.
So what are the series of tasks I have discussed in LODs? They're enough in the real time,
Okay.
like coloring with the row grand totals or coloring with the column grand totals or comparing each and every category with the selected subcategory, or in fact like how to color with only one dimension if the view contains two dimensions. All these type of requirements will get in the real time. Just I have taken each and every requirement in the form of one task and I have explained. So in the LODs, each and every task is enough.
Okay.
If
So
you want,
these examples are somewhere in the project you experience. Uh,
yeah, yeah, yeah. All these are the tasks which I have experienced in my most recent project, and I have grouped everything in the form of multiple tasks. If you practice these 12 tasks, and if you understand it in the perfect way, it's enough. To work with LODs is enough because each and every task is of one pattern. Okay.
okay. Okay. That's great. Thanks.
Yeah. So any other questions, guys? Any other questions? So let's move on to the next level of LODs. So the other part of the LODs is so first after working with the task we should know about the behavior of the LODs. So we have done few tasks on fixed, include and exclude. But internally how these LODs will work, or at least we should know about the behavior of these LODs. So now let's talk about the behavior of those LODs. So always the LOD expressions will have three types of behavior. If we talk about the behavior of LODs, we have three types of behaviors. So always the LOD expression would be either coarser, okay, same or finer. Coarser, same or finer, okay. Always the LOD will exist in either one of these three behaviors. Number one, coarser, number two, same, and next number three, finer. So what is coarser? Before talking about the behavior, so first we have to be clear on one part. So if we're talking about the level of detail, if we're talking about the LOD, we have the LOD at two levels. Number one at the data view level. Number one at the data view level, and number two at the expression level. Okay. If we're talking about the level of detail, by default at the data view level, we are having one level of detail, and number two at the expression level also, we are having some level of detail. So if you take for example this task here at the view level, we are having category, and even at the LOD level also we are having category. At the LOD level also here we are having category. So it is the expression and it is the data view. So what about cursor then? What about cursor? So if the data view contains more number of dimensions, if the data view contains the more number of dimensions than the LOD expression, then it is called as cursor. What is cursor means? If the data view contains the more number of dimensions than the expression, then it is called as what? Then it is called as cursor. What does it mean? What does it mean? Let's say for example, I'm taking here continent and I'm taking here customer segment. I'm taking here continent, customer segment, and I'm taking sales. And here in my view level, my view LOD is what? In my view level here I'm having continent wise, customer segment wise, total sales. In my LOD expression I'm taking here, I'm taking here fixed continent. If I take fixed continent, sum of sales, if I take fixed continent sum of sales. So now here in our LOD expression, here how many dimensions we are having? Here we have only one dimension. What about the view? The view contains two dimensions. So if the view is having the more number of dimensions than the LOD expression, then it is called as coarser. Okay, it is called as coarser. Okay, what is coarser means? If the LOD expression is pointing to the, okay, if the LOD expression contains a lesser number of dimensions than the data view, or in other words, if the LOD expression contains the subset of dimensions when compared with the data view, if the LOD expression contains the subset of dimensions when compared with the data view, it is called as coarser. Next, what about finer? Finer is opposite to the coarser. Finer is opposite to the coarser. In the coarser, data view contains the more number of dimensions than the expression. Then what about finer? Finer is just opposite to the coarser. So it means if the data view contains the lesser number of dimensions than the LOD expression, if the data view contains the lesser number of dimensions than the LOD expression, then it is called as finer. So what does it mean? Let's say here I'm taking only continent, whereas in my expression here I'm taking continent comma customer segment. Okay, so in the LOD expression here I'm having two dimensions, whereas the data view contains only one dimension. So here my data view is pointing to the superset of dimensions of my LOD expression. Here the data view is pointing to the superset of dimensions of my LOD expression. So it is called as finer. What about same? What about same? If data view and expression contains the same number of dimensions, if the data view and the LOD expression contains the same number of dimensions, then it is called as the same behavior. Always the LOD keywords will work in the, always the LOD expression or LOD keywords will work in these three ways, either coarser or same or finer. What is coarser? If the data view is having the more number of dimensions than the LOD expression, it is called as coarser. What is finer? If the data view is having the lesser number of dimensions than the LOD expression, it is called as finer. What about same? If the data view and the expression are having the same number of dimensions, it is called as the same behavior, right? So now let's try to identify each and every LOD keyword behavior. If you take fixed, how the fixed will work? Let's identify the fixed behavior. So what fixed will do? Fixed will fix the aggregation only at the LOD dimensionality, right? Fixed will fix the aggregation only at the LOD dimensionality. So it means if you go to Tableau, here I am creating a new sheet. So in my view I am taking continent. So in my calculation I am taking fixed. So here if you take fixed continent comma country, sum of sales. Now this fixed is going to compute at which level? This fixed going to compute at which level? Here the fixed going to compute at the level of both the continent plus country. So what about the data view? The data view is having only one dimension. What is that? Continent. So if the LOD expression contains more number of dimensions than the data view, it is called as what? It is called as finer. Okay. If the LOD expression contains the more number of dimensions than the data view, it is called as what? It is called as finer. So fixed will work in the finer way, because this fixed is going to compute at which level? Even though in my data view, here as my data view is having the continent, It is going to give us the output as what? Continent wise, country wise, total sales. Let's assume that here I'm having only continent. If I have here only continent, so in my view I'm having one dimension, in my LOD expression also I'm having one dimension. So it is called as what? Same. So fixed going to work in the same way, final way. And let's say in my data view, here I'm having one more dimension called as customer segment. In my data view here I'm having two dimensions, whereas LOD contains only one dimension. Okay, so here my data view is having more number of dimensions. So what fixed will do? Fixed will compute only at the continent level, right? Here what is the output of your here what is the output of this LOD expression? It is going to compute only at the continent dimension level, but the data view contains continent plus customer segment. So here we're having two dimensions, but here we're having only one dimension. So what does it mean? It means it is going to compute at the level of only continent. So there the data view contains more number of dimensions than the expression. It is called as coarser. So the fixed will work in all the three ways. Okay, the fixed keyword will work in all the three ways. It is going to work in the finer way, same way, and the coarser way. So next, number 2, include. What about include? So if you take here include, and in place of fixed here if you take include, so here what include will do? Include going to include this dimension in the final output, right? So here what the include going to do? Here include going to gives us continent wise. The final output of the include is what? Continent wise, customer segment wise, total sales. So in my view here we're having two dimensions, and this include, okay, also giving us the output contains the two dimensions. If both the number of dimensions are same, it is called as what? It is called as same. Let's say for example here I'm having one more dimension called as state. So now the view contains two dimensions. In the include we're having one more dimension. So include going to include this dimension also, right? What about the output? The final output would be continent wise, customer segment wise, state wise. So this LOD expression is giving us more number of dimensions than the data. So if the LOD expression is giving us the more number of dimensions than the data view, it is called as what? The final output contains continent plus customer segment plus state. So the view contains only two, but the LOD contains three. So it is called as finer. So include will work in the finer way and in the same way, but it will never work in the coarser way, because include going to include that dimension also, right? Include going to include that dimension also. If the view contains one dimension, if we take here one more dimension, the output contains two dimensions, whereas view contains only one dimension. And if I take the same dimension here in both the LOD and the data view, then both are same. What about exclude? If I take here exclude, okay, if I take here exclude, now it is going to exclude what? Let's say for example here I'm having customer segment. If I take here customer segment, now it is going to give here, what about the final output? The final output would be continent wise total sales. So the view contains two dimensions, whereas the LOD expression contains only one dimension. So here always the exclude will work in which way? In the coarser way. Always the exclude will work in the coarser way. Okay, it will never work in the finer, or it will never work in the same way. So that's why if we create any exclude field, Tableau will take the default aggregation as ATTR. So as the behavior being the coarser, every time Tableau will takes the aggregation as what? ATTR for the exclude fields. So let's see the behavior with few examples. So what about the calculation finer than this LOD? So when we call it as finer, if the calculation is having the more number of dimensions, or if the LOD expression is having the more number of dimensions than the visualization, it is called as finer. So at my calculation level of detail, here I am having two dimensions, segment and category. So let's say it got structured. Just a minute. I think it got structured. Yeah, I'm having the values like this. Okay, I'm having the values like this, and my LOD expression is fixed segment comma category sum of sales. Whereas at my visualization level of detail, I'm having only one dimension. Okay, it is my expression base. Okay, at my visualization, I'm having only one dimension called as segment. Whereas at my LOD level, I'm having segment and category. Okay, when we call it as finer, if the LOD expression contains the more number of dimensions than the visualization, it is called as finer. So it is the data I'm having. It is the data I'm having at the LOD expression level. At the LOD expression level, if you take segment-wise, category-wise sum of sales, if you take segment-wise, category-wise sum of sales, so here how the Tableau will compute at the visualization level. It is the output at the LOD calculation level. But at the visualization level, I'm having segment. Segment contains here only 4 values. If segment contains only 4 values, but the LOD expression or LOD calculation is giving us 6 values. So how the Tableau going to compute the values here? It depends on the aggregation here we will take. If I take here average, now here Tableau will take the average of these values depending on the color. Okay, here Tableau will take the average of these values depending on the color. So Tableau will place 6 here. Okay, Tableau will place 6 here. 6 in this orange. Depending on the color here, okay, here with this color only one circle is matching. Tableau going to place the 8 here. And with this color we have two values. So 7, 3. If I take the average, Tableau going to take what average of this two. So 7 plus 3 by 2, 5. Tableau will place 5 here. And if we take this, here we have two values of the same color. So 2 plus 0 by 2, 1. So the output, it depends on the aggregation we will take. Here, if I take average, here I'm taking average, okay. Yes, if I take the average here, so now it depends on the aggregation we will take. If I take your average, this here Tableau will take the average of this two, so 7 plus 3 by 2, and again Tableau will take the average of this two, so 2 plus 0 by 2, next 6 and next 8. So in this way the LOD finer will work. Let me take one example. For example, here I am taking continent. So in my view level, just I am taking only continent. Whereas in my LOD expression level, I am taking finer. Okay, I am giving the name as finer. So here I am taking fixed. I am taking continent, fixed continent, comma country I am taking. And I am taking here sum of sales. I am taking here sum of sales. Right. So now here what this expression going to do, it is going to compute continent wise, country wise total sales, right? Just click on apply. Okay, just click on apply and click on OK. Now if I drag the finer here, what output here Tableau will show? Just drag the finer and drop it into the text. Drag the finer and drop it into the text. So it is showing the values like this. Let's take the normal sheet, just drag the continent, drag the sales here. If you compare both the sheets, if you compare sheet 4 and sheet 2, if you compare sheet 4 and if you compare sheet 2, okay, here both the sheets are giving us the same output. Here both the sheets are giving us the same output here. So then what is the difference between fixed and the normal sale? This final is giving us same output here, and the sum of sales also giving us same output here. So here we have to understand one thing. So that is, if you go to the final, here the internal expression is giving us what? Here the internal expression is giving us continent wise, country wise sum of sales. So on this, on the output of the final, here what I'm doing here, summation. On the output of the final, here again I'm doing what? Summation. So here what this internal LOD is giving us is, if you take the continent and if you take the country, take the continent and if you take the country, and if you take the sales. So it is giving us continent wise, country wise sum of sales, right? So internal LOD is giving us continent wise, country wise sum of sales. And on this, if I perform summation here, so here how to get a summation? Just add the total, add subtotal. How to add subtotal? Analysis. Totals, add all subtotals. So what is the total value of Africa? 2.071 million. So the same output here Tableau is showing for Africa. So instead of taking sum here, if you take here, let's say the max in Africa, which country is having the maximum total sales? Egypt is having the maximum total sales. So if you take the max here, right click, go to measure, just click on maximum. So in Africa here, which one here Tableau is showing? In Africa here Tableau is showing us 827. Sorry, in Africa here Tableau is showing us a maximum sale of 827,000. If you go to the sheet here, which country is having the highest sales? Egypt. And if you go to Asia, here which country is having the highest sales? China. So 3.6 million. So 3.6 million. And if you go to Australia, here which country is having the highest sales? Again Australia. If you go to Europe, here which country is having highest sales? Okay, I believe it's France. So it is showing, yes, it is showing us France. So in that way it is showing us the maximum value. Now here you may get one more doubt. Now on this sum of sales, we take the max of sales. Now what would be the output? We take the maximum. It is giving us what? It is giving us the maximum sales transaction amount. It is giving us the maximum sales transaction amount for each and every continent. Okay. So it is the maximum total sale value for every continent among all the countries. So it depends on the aggregation we will take. Here if we take the average, now it is going to find out what the average of all the, it is going to find out the average of all the countries in every continent, right? So in this way the final going to work. So the final output, it depends on the aggregation we will take. So here the fixed will work in the final way, and also the include will work in the final way. So if you take include also, let's say here I'm taking here maximum. Okay, here I'm taking here one more expression. I'm taking here include. I'm taking here include country sum of sales. So now it is going to use us what? It is going to use us continent wise, country wise total sales. If I drag the include again on the include it is going to take what? Summation. Again on the include it is going to take what? Summation. So if we take some other aggregation, let's say maximum, now here both the outputs are same. So now in this way guys, the final will work. So any questions on the final guys? Any questions on the final?
Prajwal, Sunil here. So which one is preferred for LOD calculation or the normal calculations?
I didn't answer the question.
Which is preferable? Like for the calculation part, when you say that it's showing the same value, but if we have more dimensions, then
no, actually here the normal calculation is not showing the same value, right? Here both are the LODs one, right? One is fixed, other is include.
Yes.
So if you want to rate the include and fixed, then just go with the fixed, because where the fixed will execute. Morning we have seen, right? You see the execution order.
Yeah.
So which one will execute first? First the fixed will execute, because fixed will execute before the dimension filters.
Yeah.
Then go with the fixed.
Okay. Thank you.
Yeah. So behind the scenes, the LOD expression will calculate like this. So if you take this expression, fixed segment category sum of sales. So behind the scenes, the LOD expression going to compute segment wise category if I CS, whereas in the dimension I'm having only segment. So if we take the aggregation average, just Tableau will take the average of these three values and will place an average here. So we'll see the end result like this. So next, it is as I have told, the LODs will execute as the part of the SQL query. It is a SQL query, okay? So that's why if you see the LOD keywords are the part of aggregations. Next, what about cursor? So what is cursor? So if the visualization is having the more number of dimensions, so my vis LOD contains two dimensions, category and segment, whereas my calculation LOD, my expression contains only one dimension, that is segment. So if we take fixed, what fixed will do? Fixed will take the expression only at the segment level, right? So these are these are the values of my the calculation of the LOD. The LOD calculation is giving us the output like this. Then how it is going to place the values at my visualization level? Just it is going to duplicate the values, or it is going to replicate the values. So when Tableau will replicate the values while working with the LODs, with the behavior is cursor. This point is at most important. Okay, if you're working with the LODs, you have to keep this point in your mind. So if the behavior is cursor, then Tableau going to replicate the values. So it is going to place the 10 and 10 here because the color is matching, and 2 and 2 here, 6 and 8 here. Okay, I will show this. Let's say for example, so what is the meaning of cursor? If the view contains the more number of dimensions than the LOD expression, it is called as the cursor, right? So which LOD keyword will act in the cursor way? Fixed and exclude will work in the cursor way. So just create a new sheet. I'm taking continent. I'm taking customer segment. Okay, so now just create a calculated field. I'm taking fixed. So I'm fixing at the continent level. I'm taking fixed continent. Right. I'm taking sum of sales. I'm taking sum of sales. So it is called as cursor, right? Because LOD expression contains only one dimension, whereas the view contains two dimensions. Click on, it is giving us errors because I think already we are having one more field. Oh, bad character. Yes, it's not the curly bracket. Just click on apply and click on OK. Drag this fixed and drop it into text. You see here for every continent it is repeating the values. So when Tableau will replicate the values means that the behavior is cursor. Now instead of taking the continent, if I take the customer segment, as continent being the outer dimension, it is repeating the values for every continent. If I take the customer segment, it is going to compute sum of sales at which level? It is going to compute sum of sales at the level of customer segment. See here, in every continent per consumer the value is same. If you keep only consumer, okay, see here, for consumer the value is same across all the continents. So it is repeating the values for all the customer segments. So for all the customer segments here, in every pane, we can able to see only the same value. Okay. So now if I take here exclude, because exclude also will work in the cursor way. Here if you want only at the continent level, we can take here exclude continent sum of sales. So it is going to compute at which level? It is going to compute at the level of customer segment. Once drag that exclude, drag it and drop it into the visualization. So you see for exclude, it is taking the aggregation node ATTR, because okay, always as the exclude will work in the coarser way, the default aggregation is ATTR. Now on the exclude, if you change the aggregation, let's say to sum. If you change to sum for exclude, the values are same. If you change to average, the values are same. If you change to, let's say, minimum, the values are same. So if you change any aggregation on the exclude, the values won't change. It is also the another most important point. On the exclude, the default aggregation is ATTR, and on the exclude, if you change the aggregation, the values, it will never change. Because we are excluding one dimension and we are getting only the other dimension. On the other dimension, if you take any other aggregation, okay, it is going to give the same values. Then what about fixed? We go to fixed, and if you select average, okay, see here, it is also going to give the same values, because already in the inner LOD expression we're finding what component wise sum of sales, right? So for each and every component we're finding here we're excluding component, so it means we're finding customer segment wise sum of sales. So customer segment wise sum of sales means for every customer segment it is going to show the total sales. So on that every value, if you take average or if you take max or if you take min, the output would be same. Okay, the output would be same. Right? So it is the behavior of the cursor. So it is a SQL query. Next, okay, one exceptional case. What will happen? So I think I have shown you this, right? See here. So in my dimension I'm having two dimensions, segment and category, whereas my LOD having only segment. So it is having three values. So for every segment it is going to replicate the values. Okay, for every segment it is going to replicate the values. Behind the scenes, LOD will calculate like this. So one exceptional case. What will happen if my LOD contains one dimension and my view contains some other dimension? Okay, it is called as a disjoint behavior. It is called as the disjoint behavior. Okay, it is the exceptional case. Let me take here one expression. I'm taking here continent. Okay. Whereas in my LOD I'm taking fixed to. I'm taking fixed customer segment I'm taking, and I'm taking sum of sales. Okay, so in the view here I'm having continent, and in my LOD here I'm having customer segment. So this behavior is called as what? Same. But even though as the behavior is same, but here these two dimensions are different, right? Here this inner LOD going to give us what? This inner LOD going to use us customer segment wise total sales. Let me take a new sheet. Inner LOD going to use us the customer segment wise total sales. Then what about then here how it is going to calculate the the outer LOD expression or the visualization. So if you drag that fixed to here, let me drag the fixed to, drag it and drop into the text. So if you go to the sheet, here, what we're seeing here we're seeing the customer segment wise sum of sales, right? So every component is having 4 segments. Okay, every component is having what? The 4 segments. If you drag the component, in every segment here we're seeing, in every component here we're seeing the 4 segments. So now it is performing the summation of all the 4 segments. And by default it is giving us the 30.4 million. So it means it is giving us the values depending on the aggregation we will take. If I take here average, it is going to find out the average of the values. If I take max, it is going to return the maximum value. So the output, it depends on if I take max here, so here which segment is having the maximum value? Okay, which segment is having the maximum value? The corporate. So here this customer segment is part of all the continents. What will happen if I have the disjoint dimension with the disjoint values? So what does it mean? For example, I'm taking here department and I'm taking here category. So in this department, I'm having 4 categories. In this department, I'm having some 9 categories. But these are the disjoint categories, right? It means one category is not repeating in the other category. Whereas if you take the content and the customer segments are repeating in every content. Now I will take here department, and here I will take fixed. Here I will take fixed, and here I will take fixed of category sum of sales. Okay, I will take the expression like this. So hit apply and hit OK. Now drag fixed tree and drop it into the text. So it is giving us the values like this. So in the furniture we are seeing the sum. In the office supplies we are seeing one value. In the technology also we are seeing one more value. So what this value indicates? This value is a summation of all the 3 categories in that particular furniture department. So let me take here one more sheet. Let me take here department and category. Let me take here sales. So here how to get the totals analysis, totals and all subtotals. So what is the subtotal value in the furniture? 10.5 million. In office supplies 7.6. In technology 12.2. 12.2. Here how much value we got? The same 10.5, 7.6 and 12.2. Okay, just it is finding the summation. If we take here the maximum, so in this furniture department, which categories are maximum sales? Tables. In office supplies, I think it's storage and organization. In technology, office machines. Just check the output. Instead of taking the max, you just take the instead of taking sum, just take the max. So if the dimensions are also disjoint, the output it depends on the aggregation we will take. Okay, the output it depends on the aggregations we will take. So it is going to replicate the values, and the output it depends on the aggregation. If you take the average, it will take the average of these values. So these are the behavior of the LODs. So always the LODs will behave in the 3 ways. Okay, they are finer, coarser and same. Again, I'm telling this behavior is very, very important. If you're working with the huge amounts of data, sometimes if you get the wrong output, and if you want to perform some kind of unit testing, or if you want to analyze the output, you should know the behavior. So any questions on this LOD's behavior? Any questions on LOD's behavior, guys? So before starting this nested LOD expression, I want to take 5 minutes break. I'll join within 5 minutes, guys. Okay. Let's continue with the nested LOD expressions. So every time with a single LOD, we cannot achieve the required results or the required outputs. So Tableau is like the mathematics case. Okay, just Tableau is an application where we can able to execute the logics. Tableau is like the doing mathematics with an application. Okay, so we have to take multiple formulas within one calculation. So what is nested LOD? If you take one LOD inside the other, then it is called as the nested LOD. If you take the nested LOD, where the execution will start? Always the execution will start from the inner LOD. So let me explain this nesting with one example. I would like to find out number of unprofitable orders. Try to understand carefully. Number of unprofitable orders per customer. For every customer, how to get the number of unprofitable orders. Okay. So I would like to do this task on the global superstore. Not in the sample superstore. I'm connected to the global superstore. So actually today morning I have sent the global superstore and CO2 data source to Satish. If you don't have those, just once contact Satish. So just I'm connecting to the Tableau repository, data sources, not archive, I think it's connectors. Connectors, yes, global superstore. So one shortcut in the BI is, if you really don't understand the question the proper way, just break down the question into two parts. Okay, just break down the question into two parts. Here the first part of my question is number of unprofitable orders, and the second part is per customer. First, let's find out the number of unprofitable orders. So how to get the number of unprofitable orders? So how to get the number of unprofitable orders? So just take this one, connecting to orders. So each and every order is having the order ID. Just go to the sheet, just create a new sheet. From the global superstore, just drag the order ID and just add all the orders. So we have 25,000 orders. Just take the profit and just sort the view in the ascending order. So here all these orders are giving us what? Here all these orders are giving us the losses, right? So just compute for every order ID. Just compute for every order ID. Okay. So which are unprofitable. So how to compute? I'm creating one calculated field. So how to get for every order ID? Number of unprofitable orders. The calculation is fixed. Calculation is fixed order ID. Calculation is fixed order ID. Okay, just for every order ID we have to compute. Total profit. So just I'm taking order ID wise total profits. So it is going to give us order ID wise total profits. Just I'm taking this complete expression less than 0. Okay. So here what is logic going to do? This logic going to check for how many orders the total. Okay, for every order it is going to compute the total profits. After computing the order ID wise total profits, it is going to check for how many orders the profit is less than 0. If it is less than 0, it will indicate with true, else it is going to indicate with false. Just click on apply, click on OK. So it is being the boolean field, it is going to create under dimensions. Here number of unprofitable, just drag it and drop it into color. So Tableau is showing false and Tableau is showing it true. True indicates unprofitable orders. Okay. So how to convert the true false to zeros and ones? Morning I have told, just take here int of it. Just take here int of it. Just take here int of it. So if you take int of it, click on apply, click on OK. Oh, not in that. We'll have to take int in the bracket. Just take int of it. Okay, just take int of it, click on apply and click on OK. Now your Tableau is giving us zeros and ones. So for every customer we need to find out. Okay, for every customer we need to find out. I'm taking customer ID. Okay, for example, if you take one customer, if you take this customer is having 3 unprofitable orders. So how to get the unprofitable orders for every customer? Just go to this logic. Okay, just go to this logic. Here, as I want to compute for every customer, I'm taking here fixed customer. Just take the curly bracket and just end the curly bracket here. I'm ending here. So I'm taking fixed customer ID, fixed customer ID. I'm taking here sum of I'm taking here sum of this. Okay, just for every customer ID, I'm getting the summation of all the ones. Summation of all the ones. Click on apply and click on OK. So here just I'm computing the number of unprofitable orders per customer. Just create a new sheet. Once drag the customer ID, drag this unprofitable orders, drag it and drop into text. So this customer is having 3 unprofitable orders. Once compare the output. So if you see this A315, so here this customer is having 3 unprofitable orders. We go to the sheet here, here tableau is showing 3. So here the question is how this LOD going to execute. So here we have one fixed and also here we have one fixed. So first this inner LOD going to execute. So if you take the nesting expression, always the nesting expression will work in a similar way. So first the inner LOD will execute. After the execution of the inner LOD, it gives the output to the outer LOD. So based on that, the outer LOD going to execute. Okay, based on that, the outer LOD going to execute. So here we are having fixed. The fixed going to fix the calculation and at this dimensionality level. So what will happen if I have some other keywords? If I take an include or exclude, how the include and exclude going to work? Okay, how the include and exclude going to work? So I'm taking one expression. I'm taking fixed of include. I'm taking fixed of include. I'm taking fixed continent. Now take continent from the continent is not there in the global superstore. So I'm taking fixed country. I'm taking sum of. So to get the sum here, I'm taking on LOD. I'm taking include market, sum of sales. Include market, sum of sales. Just I'm adding the LOD here. So here I'm taking sum. You can take here sum. So how this LOD going to work? Just click on apply, click on OK. So in my view here I'm taking, let me take here category. I'm taking here category. Let me drag fixed of include. If I take here fixed of include, it is giving us only one single value. Okay. So 12.620, 12.641, 12.631. It is giving us similar value. So here what is happening here? So if you see the inner LOD, what inner LOD is doing? Inner LOD is computing. Here in first the inner LOD will execute. So here what is the inner LOD include? What include will do? Include going to include the dimension at the visualization plus LOD. So it is going to give us category wise, market wise, sum of sales. So just create a new sheet, take category wise, market wise, sum of sales, right? So after finding that category wise, market wise, sum of sales, again on the outer LOD, here we are taking summation, here we are taking sum, right? So we are computing here sum. So just take it total analysis, totals, and also totals. So here we got the value like this. Okay, here we got the value like this, like 4.1, 3.787, and the 4.7. Okay, so it is a summation of the category wise, market wise, sum of sales. Now after finding this, we are fixing at which level? Here we are fixing at the country level. Here we are fixing at the country level. So just take the country here. So if you take the country, if you take the country, so for this country, okay, we're fixing as here we're fixing at the country level. So here we got the output like this. Here we got the output like this. Okay, so if you take this Afghanistan in this particular category, furniture, it's the value. In office supplies, it's the value, and in technology, it's the value. So again, as here we're fixing at the country level. Okay, again here on the country, again here on the fixed here, what I'm taking on the fixed, again I'm taking sum. So if you take the summation of all the countries, just add the total. Just add the total. So to add the total, is going to give us, okay, it is going to give us this value. So instead of taking here sum, let me take here max. Let me take here max. So in all the categories, okay, in all the categories, here Tableau is showing us the max. So here how Tableau is computing the maximum. So just in the visualization, just there we're having only the category, right? So it is going to compute the category like this. So in every category, it is taking the maximum value. So the maximum total summation would be 2.0. So let me do here one more thing. Instead of taking here sum, let me take here max of it. So this inner LOD is going to give us what? The maximum of category wise, market wise sum of sales. I'm taking category. I'm taking market. And I'm taking sales, sum of sales. So here in this category, which market is having the highest? Okay, APAC 1.343, and in office supplies EU, and in technology again APAC. Okay, again APAC. Now on the outer, we are fixing at which level? On the outer visualization, we are fixing at the level of country. If you take the country, and if you take the sales, take the country and if you take the sales, so these are the existing sales values, but as to the sales, it is giving the but for the country, it is giving the value from this market plus category. Market plus category, if you see the output, yes, drag here, fix it, sorry, let me take here max. So again it is giving us the output like this. Okay, so here internally we have max, and again on fixing the country, on the country I'm taking the maximum value of the country. So just take the country, just take here the country. So if you take the country here, which country is having the highest value, so that we can able to identify it. So we go to the US. We go to the US. I think if you take the summation of the US, you just take add all totals, analysis totals, add all totals, add all totals. If you see all the values, the US is having the highest value. Okay, US is having the highest value, which is 2.297 million. So here we are seeing that highest value because US is having highest value in all the categories. So the nesting of the LODs, first we'll take the dimensionality and the visualization in the inner LOD. In the outer LOD, again it won't take this dimension. Okay, only at the time of evaluation of the inner LOD it is going to take this dimension. After that, okay, whatever the output we got in the inner LOD, that inner LOD output will be inherited to the outer LOD. So it's all about the LOD nesting. It's all about the LOD's nesting. So if you see here, for example, here I'm having two LOD expressions. So the inner LODs include customer, sum of sales. So at the view, you take any dimension. At the view, you take any dimension. Let's say, for example, at the view I'm having state. If you take state, this include going to use what? State-wise, customer-wise, sum of sales, and the outer LOD is going to fix at the state level. Whereas if you take this expression also, it is going to use us state-wise, customer-wise sum of sales, and on the output we are taking the average. It is going to find out state-wise, average-wise, okay, state-wise, average-wise sum of sales given by the combination of both state and customer. Okay, so it is the nesting of the LODs. So it is an internal expression. Finally, what about the limitations of LODs? So currently the LODs they are not supporting on all the data sources. So the LODs they will support only on the few. So the list of data sources which are not supported by the LODs they won't support on the multi-dimensional data sources, which means cubes. And on the Google BigQuery it is not supporting, and even on the Microsoft Jet database it is not supporting. Like it won't support like Z connections of the text Excel, and even it won't support the Teradata, Netizen, and on the big data systems like Hive. And even if you want to try to connect using ODBC, we have only the limited connectivity using the ODBC. And even like we have some other limitations for LODs. So LODs they won't be materialized in the Tableau data extracts. So what does it mean? Here we are creating this LOD fields, right? So here we are creating the LOD fields as the calculated fields. So after creating the LOD calculated fields, if you take the extract, those fields they won't save in the Tableau data extract. So they won't be materialized. Means those fields they won't save in the Tableau data extract. And till Tableau 9.1, we cannot use sets, combined fields, bins, groups, parameters, table calculations, aggregate calculations, include, exclude, LOD calculations in the dimensionalities. In the dimensionalities, we cannot use sets, combined fields, bins, groups, all these things till 9.1. I will show you. Okay, now I think I'm in 9.2, I believe. Yes, I'm in 9.2. I'm taking one set in the dimensionality. I'm taking fixed. I'm taking top. I think here I'm not having any sets. I'm having some sets here. Or let me do one thing. Yes, here I'm having some sets. Let me create a calculated field. I'm taking fixed. I'm taking here top customer set. Sum of sales. You see here the calculation is valid. Okay, from 9.2 we can take sets. From 9.2 in the LOD dimensionality we can take sets. What about till 9.1? Let me open 9.1. And also here we cannot use, as I told, combine fields, right? Let me combine two fields. In 9.2 let me combine two fields. I'm combining continent plus container. I'm taking C plus CO. Just click on apply and click on OK. So I'm creating a calculated field. Here I'm taking fixed C plus CO sum of sales. Okay, now the calculation is valid. So we can use sets, combined fields in 9.2. What about bins? I think here I'm having one bin called as profit bin. Let me take the profit bin. Okay, if I take the profit bin, the calculation is valid. So we can use the profit bin also. What about group? What about the groups? So no group. Yeah, here I'm having one group called as supplier. Let me take the group, supplier group. So you enter supplier, we cannot see that. Yeah, we can able to see that field name here. You go to the errors. So it's here, operation on field supplier is not permitted. So we cannot take groups even in 9.2 also. On 9.2, even we cannot take the groups also. Let me go to 9.1. I think it is connecting. So sets, combined fields, bins are possible in 9.2. Groups are not possible. What about parameters and table calculations? What about parameters and table calculations? It's in 9.1 guys. So I'm showing in 9.1. So I'm taking fixed countries, sum of sales. So if you take this here, now we take this is set, right? You take this set. So here combined fields and sets are not permitted in the dimensional declaration. Till 9.1 we cannot take combined fields and sets. So what about bins? What about bins? Let me take the profit bin. I think it is not showing that bin also here. Profit bin, just drag it and place it here. So even if I drag it and place it here, it is not taking that. It means it won't support bins. Just drag supplier and place here, it won't support the bins also. So till 9 it won't support, till 9.1 it won't support that. What about parameter? What about the parameter in 9.2? Just see in 9.2, I'm having one parameter called as category. I'm taking the category parameter. Now it is giving us what error. Click here. So columns in the dimensional declaration cannot be constants. It means even we cannot take the parameters also. And even in fact if we take any table calculations or aggregate calculations, okay, exclude and include, they cannot be used in the dimensionality expression. And next limitation, we have to use only the field names in the dimensionality expression. It means we have to take only the date fields. For example, if we take the order date, we have the order date in the superstore. Order date is a combination of what? Day, month, year. On the order date, if you want to take only year, or if you want to take only month, if you take year of order date or if you take month of order date, then it is not valid. Okay, then it is not valid. So what does it mean? Here I'm having order date. If you take order date is valid. And if you want to get year, if you take year of order date, if you take year of order date is not valid. Okay, once see the error. Only column names are permitted in the dimensionality declaration. So what is year? Year is one function, right? So it won't allow the year. So in the dimensionality, just you have to take only the field names. Whereas if you take any function, it won't be allowed. So if you use, let's say for example, here I'm using one important note point is here, let's say I'm taking only order date. Here I'm taking only order date. So I have to remove this brackets also. Okay, so just click on here. I'm taking order date. So in my view, I'm taking one more order date. So in my view here, I'm having year. Here I'm taking order date. So what is order date? Order date is a combination of a day, month, year, right? But in my view, I'm having only year of order date. Here I'm taking exclude. So what exclude going to do? Exclude going to exclude, right? Here what it is going to exclude? In the view I'm having only year, but here I'm taking the complete order date field. Here what is going to exclude? Just check it once. Click on apply. Click on OK. Let me drag the calculation. So now it is showing us the same value. It means it is showing us the sum of sales at the table level. It is showing us the table scope for LOD. So if you take any date field with the required hierarchy level, Tableau automatically identifies the hierarchy. It means it is going to exclude the year. If the view having the year, exclude going to exclude year. If the view having the month, exclude going to exclude the month of order date. So what this point states here is, if you use exclude order date sum of sales and have order date in our sheet, Tableau will recognize the date hierarchy and automatically excludes the date part from calculation level of detail. Next. So next on the part 3.
If there is year and also quarter, right? In that case, how does it become if there are more than 2 dimensions with the same name?
Yes, that's a good question. So here I'm taking here year and quarter, okay? And here I'm taking exclude order date. So let me click on apply and click on OK. Now it is excluding both. It is showing here what 30.4 million means. Let me show you one more thing. Let me take here sales. What is sales value at the data store level? 30.4 million. Here which one here Tableau is showing here 30.4 million. It means here it is excluding both the year as well as the quarter. So Tableau automatically excludes the date hierarchy.
If the multiple dimensions are there with the month-wise differentiation of the sales, then how we need to do, Prajwal?
No, month is the date part, right? Month also belongs to the order date. Even though if you take the month here, the value is same. If you take some other dimension, let's say for example region, the region is different and the order date is different. Now it is excluding the order date, it is giving the values at the region level. Here the point. What?
Yeah, go ahead.
Yeah.
I would ask.
Here the point is, if you take the order date here and the view contains the different date hierarchies, it means year, quarter and month. Tableau automatically excludes all the hierarchies of the order date.
Right. No, my requirement is something like this. Like they have multiple dimensions and month-wise sales they want. What we need to do?
Then take only fixed, okay? Fixed month.
Fixed month.
Yeah.
But can we take only month from the order date? We cannot do it only month from the order date, right? So I didn't get that point.
No, create a calculated field. Only we can use the expressions, right? How to get the month?
Yeah, month of.
Let's take the date name. Date name going to create the field of type month, right? Just take the date name of month from order date. Yeah. Just click on apply and click on OK. Now just create a calculated field. Here take your fixed. Now take month. Sum of sales.
Okay. So expression which is the calculated field can be used in again one more calculation. That's right. Okay, got it. Thanks.
Okay. Next. So on the part 3 of the LOD, we cannot use any table calculations and the ADTR functions. So and the next limitation is as include and exclude, we cannot use them as dimensions. If you try to convert any include or exclude fields, Tableau it won't convert the fields to the dimensions. If you drag exclude, it won't convert, and if you drag include also, it won't convert. And if you take let's say for example fixed month, and we take here index is a table calculation, right? So just see the level of detail expressions cannot contain table calculations of the ADTR function. And while performing the blending, If you take dimension from one source and if you take the measure from the other source, okay, then the level of detailed calculation will be invalid. All the dimensions in the dimensionalities should come from the same data source, okay, and even the measures cannot be used from the secondary source. Okay, these 3 points will tell the same thing. One thing, if you're performing the data blending and if you're using the LOD expressions, so where the data blending will take place, the data blending will take place at the Tableau level, where the LODs will execute. LODs will execute at the data source level. So that's why in the LOD expression, the dimensionality and the measure should come from the same data source. So these are the limitations of Tableau. Let me walk through the limitations again. What are the limitations? The LOD expression, they won't materialize in the Tableau data extracts, and we cannot use parameters, table calculations, aggregate calculations, groups in the dimensional expression from 9.2 up to 9.1. We cannot use all these sets, combined field space groups, and also we have to take only the field names in the dimensionality expression. If you take any function or if you take any logic, it won't work. And with the date fields, Tableau automatically identifies the hierarchy. We cannot take any table calculations in the aggregate part, and we cannot convert include or exclude fields to dimensions. And if you're performing the data blending, both the dimensionality and the measure should come from the same data source. So if it is coming from a different data source, LOD is not valid. So in the current versions, these are the limitations. In the upcoming versions, hopefully in 10 we can do this. Okay, so it's all about a 17 scenario LOD space. So any questions on this LODs? Any questions on this LODs?